to speak to us about a whole host of issues about the Indian space program and ISRO's projects. We're joined by Dr. S. Somanath, Chairman ISRO and the Secretary, Department of Space. Sir, thank you for making time for WION. So first up, sir, just a personal question. How are you feeling now? How's your health? This is something that's concerned a lot of people. So please let us know, and we want to hear it from you.
I'm perfectly fine. There is no problems. So I'm very healthy now.
So first up, sir, recently you just visited Europe. You had a meeting with the top bigwigs of the European Space Agency. So please reveal what this was about, because Europe is a significant partner for India, be it GAGAN or even joint projects. So tell us more, please.
In Europe, there is something called European Space Agency, which is a group of all the spacefaring or space agencies of Europe nations. So I had an interaction with ESA at their headquarters, and also I addressed their annual meeting where they wanted to know about our programs and the success that we had in the recent times, and how Europe can collaborate with India strongly in the future, because we have been anyway collaborating in many areas. And another important player in Europe is the CNES, which is the French National Space Agency. So I also had separate discussions with the CNES to look at the scientific collaboration that we are already having, and we have very strong interaction related to GAGAN program, human space flight program, and they are already helping us in many ways. And also looking at joint missions that we have been doing in the past, like starting from the Megatropic, Saral, and now the Trishna, and how to take it forward in the future. Very important industrial player in France is the Ariane Group, which is again responsible for carrying out the realization of the Ariane 6 rocket, and also provide related services for the entire Europe. So which is again funded fully by ESA to produce the rocket. So I had a meeting with them and looked at their facilities and how collaborative development of the future launch vehicles, especially the reusable rockets, which can vertically land, and then locksmith and engines that can be developed, how we can collaborate in this aspect. That was discussed with the Ariane Group. And there are many other industrial players also in and around Europe, which I had a short interaction. So the whole of that program was looking at how the stronger collaboration than what is existing today can be engaged, especially with the not only from ISRO, but also for the industries in India to work together, especially in aerospace manufacturing area, collaborative development of systems. In fact, one of the two important industrial associates with the ESA and CNES were also there at that time in India, we're discussing with ISRO on those topics. So I only complimented that work which is already happening.
So Europe, not just with satellite projects and rocket engines, also Gaganyaan is a major focal point where India and Europe are working together. So space medicine, they have a legacy of experience in that domain and also in space suits and things like that. So would we also be looking into that domain?
Of course, I think we are already, as you mentioned, the space medicine, the activities, especially those doctors which are specifically trained to handle astronauts, were with us, and they helped us also to figure out how to do the astronaut training, especially the medical activities, and also equipments that are required, systems that are required to support them for that. So they were provided by them. They are also helping us in looking long term in many areas like bioastronautics and related fields, also on docking systems and many other activities.
So speaking of Gaganyaan and astronauts, a couple of months ago, the Prime Minister himself revealed the names of the astronauts, gave them the astronaut wings. So what is their current status of training? When are they heading for the US for the next leg of advanced training at NASA's Johnson Center?
They have to go now. I think the time has come for them to leave. But before that, there are some work that need to be completed. So we are trying to complete that. They need to go through the training program immediately. The launch schedule is this year itself, so it has to be completed. So we already intimated that aspect to NASA.
So Russian training and US training, Indian astronauts are getting the best of both worlds?
It has been the legacy. Even those who have been flying in Russian vehicles were the NASA astronauts who were trained in NASA facilities as well as in Russian facilities. So both of them were actually complementary. The International Space Station, still Russia and NASA are collaborating to work together. So some of those astronauts who are going to ISS are trained both in NASA facilities as well as in ISRO, in Russian facilities. So similar privileges are now being obtained for an Indian astronaut. So the whole goal of such a training program is to equip our people to handle both of them and also to give inputs on how we progress with the human space program in the future. So that's what we are looking at.
So pertaining to the first-hand experience that flying on a US rocket will give to the International Space Station. So our only astronaut reference is 40 years ago, Rakesh Sharma's space flight. So now this will be a game changer to understand what really modern day space flight is.
Okay, modern day space flight is very much there. I think new players have come into the field. The SpaceX has come. The new players, the Boeing is coming. The Blue Origin is there. Virgin Galactic is there. There are many things, new things happening. The interactions as so much with the machine, which was there in the Soyuz time, are now moving out. That you are now with the touch panel interactions and no manual operations and more autonomy, more electronics is much better. That you have interactive interfaces with the machine and the ground much better than earlier times. The training demands are much lower. It's a benign flight. The safety of the crew system has improved substantially. So all this makes a big change in the human space flight activities, but the physics of this remains the same. The skill sets required for them remains more or less the same. So still go through the traditional training program. But then possibly in the future, with the number of human spaceflight activities increasing, this traditional training programs has to become simplified because more people will have to go. I think this approach is already been taken by, I understand, taken by NASA in many of their future missions. So that is something that we are looking forward to understand.
So particularly with regards human spaceflight, we are seeing this trend today that there are more and more commercial players coming in, and there's also interplanetary exploration being planned only by commercial players. How does India view this trend? Because ours has largely been government dominated and private sector is just gradually coming up.
Yeah, it is. So you are telling the positive aspect, they are coming up. I think we look forward from them to come up strongly in the future, especially the human space flight and interplanetary and scientific activities as well, not only limited to just commercial work. So there is commercial possibilities everywhere. Even for space stations, there is so much of possibilities of commercial engagement, of conducting research. Interplanetary missions do provide an expected commercial outcome like the space mining, etc., which is yet to be proven still. But there are a lot of hypotheses, possibilities outlined in front of future exploration. I believe this will happen, and we want private sector also to come up strongly, in addition to the government funding, which is necessary at this moment, to keep the technology development, to enable private sector to come in, because immediately the return of investment will not be very much visible. So there is always a government support needed.
So the ISRO-NASA joint mission to the ISS was a government-to-government announcement. So does this imply that the US government is sponsoring India's seat to the ISS?
There is nothing like that. It is a joint mission of NASA and ISRO. So that means NASA facilitated that mission possibility. But then after facilitating that, we have to enter into a commercial agreement between the players in the US and the rocket launch agency, which is the SpaceX. So there are different mechanisms of entering the process into it, but the front end is NASA.
What will be the tangible outcomes? So once one of our own astronauts or perhaps two of them fly to the ISS, what will be the tangible outcomes, and how does it positively impact the development of Gaganyan's program and the progress of Gaganyaan?
What you said precisely, that is a goal. We must be able to get more and more inputs on the development of Gaganyaan and utilization of the Gaganyaan for the future. See, I look at it from the point of view of Gaganyaan becoming a global route for human spaceflight. If it has to happen, then it must get international accreditation in a manner. They must all certify, yes, Gaganyaan is a good mission, and the people who have done it are the experts in that domain. And our people also, an international traveler also can travel in one of our Indian craft, possibly to international space station or future space stations which we and others are going to build. Or possibly our Gaganyaan can be used for crew and uncrew and cargo transportation for international users on a commercial basis. If all of this has to happen, we cannot do it in isolation. It has to be done as in a collaborative manner. Everybody must be a part of it. They must also get exposed. So this is one of the goals. Gaganyaan should become a global identity. So with that, when our astronauts travel in international space stations and then do such work, that connection will happen.
So 2024, you said, is the year of Gaganyaan preparation. How far have we come? What is the kind of work that's going on? Just a gist of it.
Uh, Gaganyaan is progressing very well, especially with respect to the missions that we have planned this year. This year we have planned at minimum major 4 tests. One is the unmanned mission G1, for which the rocket is almost ready. The crew module is currently under integration. The service module also is now currently going through the propulsion and wiring and other activities. So both of them have been recently joined together to see how they look like, the interfaces. So we have verified that. So that is getting ready. The crew escape system is also ready. So the very sheer amount of work is pending. So that is everybody is on that now to make the G1 mission happen. After that, we have a TV D2, which is a second test vehicle mission to show the abort condition at a higher Mach number. Last time we did at the transonic Mach number. Now we have to do it Mach 2 and above. So this will be done now. So for that, the vehicle is already moved from LPSC to IPRC to Sriharikota. It's already here at Sriharikota. Then the crew module is being delivered today from an industry for assembly. So that's the progress there. Then we have to do an integrated airdrop test. For that, hardware has already reached Sriharikota. The helicopters have come and tried out. So in fact, we want to do this month. Hopefully, it will happen this month. Then we have another important mission called pad abort test, which is to demonstrate the abort scenario from the lift off just before the vehicle takes off. If an abort is initiated, what will happen? For that, hardwares are getting ready. That will be done by the end of this year. And if you are still very lucky and successful, then possibly one more mission of this also will happen, like including G2 or TV D3 or A1, we call it. So this is our target this year. In addition to some of the subsystem test, today I was discussing, there are many motor test, the qualification test, acceptance test, all of them are happening.
So Gaganyaan, in fact, is a stepping stone to larger things. The Prime Minister had stated that manned moon landing is something we're looking at in the long term, around 100th year of Indian independence. So how are we progressing towards that? Because that requires a lot of investment, that requires a lot of R&D, and even having operational launch vehicles that are exponentially heavier than what we have right now. So tell us, Musa.
See, there are many things to be done for having such capability in the future. For example, a space station is again a human spacecraft. It is also huge and it is very massive in size as well as mass. So we need a new rocket. The current rockets can do only a certain amount of capability. So what we are trying to do is, a new rocket development of course will take time. That's currently being configured and engineered now, and we will be seeking the approval of the government to realize it, because this also requires government funding to develop a new rocket. The second aspect is that what you can do with the current rocket with certain amount of upgradation. This is what we are trying to do. The space station's initial modules we want to do launch only using the current rocket, the LVM3, with upgradation. So that is already configured. The BAS first module is already configured. We have been series of discussion reviews to finalize it, and immediately it will start the engineering of it. Of course, the approval funding has to be sought from the government, which we are putting it up. Then we have to have a new development of environmental and life support system in that large size, which is again different from the Gaganyaan. So as I know today, that engineering and schematics of all of that have been worked out to do it indigenously. We are also talking to all the industry's users to make use of the space station once it comes up, to conduct experiments, etc. What all experiments can be done, how to collaborate with the universities and establishments and also global players to come and make use of the space station. So that dialogue is also happening between various players, how to equip the space station, how to do more of robotic activity than human flight, because every human space flight is extremely costly. So how to do it more autonomous ways than human intervention. So human has to be minimum, not too much than the past. So we are developing new robotic arms and robotic manipulators to handle crew, docking, experiments, initiation, etc. and through that model. So different ideas are being discussed. So a series of list of technologies that need to be developed towards that is being done, including new engines, liquid engines are to be developed to handle it. So that one project is going on. New robotic actuators and arms that are required to be developed is going on. New docking system development is going on. So there are many things.
Moving on from rockets to spacecrafts, interplanetary is a huge thing. That's what generates a lot of national interest and passion. So after Chandrayaan 3, what next? Chandrayaan 4, there's a lot of diagrams doing the rounds. Lupex with Japan. So, what is it that we can look forward to? Two rockets for Chandrayaan 4, perhaps, and, Indian lander, Japanese rover for Lupex. Conceptual studies are finalized.
See, these are all initial discussions which are going around, roaming, ideas being floated around, with a possibility of doing such a mission. So, but we have a finalized scheme separately, which will be putting up for approval, which is definitely the goal is to bring samples, moon samples, to back to Earth in a very cost-effective, frugal manner, as we have been doing it in the past, because going to moon requires certain amount of energy. Coming back to Earth also requires that amount of energy. That means the current rocket is just capable of going up to moon. To bring it back, you need that much of energy. So that means one rocket cannot do that. So how to use two missions to do that is a topic of discussion. Instead of developing a new rocket, how to do it with two launches, which is a very complex mission, which requires multiple docking, interfacing, etc. in the flight, which is a very challenging mission. We are grappling with that idea, how to do it very efficiently. Possibly we will find a very good solution for it. And we also are working on missions like Venus, which is currently developed fully. Lupex, of course, has been going on for last many years. We did not finalize the configuration because both sides, Japanese side and Indian side, were changing. The rocket capability was changing. The payloads were changing. So right now we have reached a certain amount of configuration, and discussions with the Japanese side is reaching final phase.
So one beauty about spacecraft is also the fact that it's been an enabler of space diplomacy. Bhutan sat, and now proposal for making one for Mauritius as well. So tell us more. What else can we expect in the pipeline that India enables other countries to use space capabilities by offering it to them?
See, we need a lot of players in space. See, a national requirement of space is one part of it, and we have been developing it and providing services. But space is a global enabler. It doesn't limit within one nation. As our Honorable Prime Minister Modi ji has declared, when we landed on Moon, Chandrayaan 3, he said, it is not for India alone, it's for the whole the world. So whenever you offer space capability, it must be for everybody. So when you want to put everybody, then they will come in only when they have they see the big picture. How that helps the nation to grow, how it increases scientific capabilities in this, how applications can be developed in the nation. For nascent countries of this nature, what you mentioned, we need some help to be extended. We were helped by big players once to create this capability. It is something that we need to do in the future, especially with a developed space capability, developed nation. We must help others to come up, not to compete with us or not to become a challenge for us, but to become useful for their nation. And if that happens, it's really a great thing to happen. We develop new markets, we develop new capabilities, and it's not only Bhutan and Mauritius. We are looking at many more nations, how this stronger engagement can be done in developing infrastructure there, satellites there, deploy applications there, and ultimately they'll find their own way.
So moving on to another high-profile satellite mission, NASA ISRO synthetic aperture radar. So one of the antenna components has been flown back to NASA. So you found out that it's not able to withstand temperatures, and you need to more enhance it to withstand higher space grade temperatures. Tell us more, please.
See, this is a decision by NASA, not by us. There were no problems with the part of the work which ISRO was doing. So this is an item which was supplied by NASA, and they had to take a call on it. They must be sure about that antenna when it is deployed, because it is so crucial for the mission. If it doesn't work, the whole satellite doesn't work. So, and it is a very proprietary knowledge, so which was developed by another company, which was NASA contracted. So there are some conditions which requires the correction. So the company should be in place. So NASA has to take it back to US to do the repair. Cannot be done here. So that is their way of working. So let them take the call, because we can't risk the mission, because it's one of the highest investment from both the sides. They are equally aware of it. We as well.
So there's been several Earth imaging satellites, conventional imaging and synthetic aperture radar. Why is NISAR being touted as the world's most expensive imaging satellite of that class, civilian satellite of that class?
I think expensive, you don't have to pay a lot of attention. There are more expensive satellites. Okay, but this particular satellite is a very complex in technology, and utility point of view is also great. I think these two are more important than the cost. See, let us look at the radar satellite. When you two radars are operating in L and S band, two bands, that it gives you a different picture of the same object that you are looking at. And you are looking at through the same eyes with two different frequency, two different bands. So it gives much better picture, especially actually you can see deeper into the surface. You can look at the tectonic movements, you can look at the green cover, you can look at ice, you can look at water, you can look at the arid zones, water moisture. So it gives agriculture, weather related and geographic information so much. And another important thing is it has a huge antenna and large swath, unlike many other radar satellites, which gives us a very high repetitivity, like 15 days you can cover the entire globe, which is a very unique feature of this satellite. So the data can actually find out very fast variabilities over a period of time. That's the beauty of the satellite.
So also coming to satellites, we've seen already space technology has been dual use since day one. But now we've seen how satellite constellations, communication satellite constellations have completely changed the face of war in one part of the world. So how does India see this? Because, we don't have constellations, but we are also in a very hostile neighborhood.
Communication is an essential in every scenario. Even your telephone networks, your fiber optic networks, your internet networks are critical for any nation, even for civilian as well as strategic use. At the time of need, then you need communication systems. Issues are then when they all secure. The civilian infrastructure is also need to be secured to handle adversaries. So that's why the space helps. The space cannot be that easily compromised. But it also works in complement with the ground infrastructure. So both are there. So the recent incidents which you are quoting would have shown the power of space than what it was used to be. Especially with the low latency communication feasibility at a LEO constellation gives a great advantage over the terrestrial networks. So this is something that nation has to look at it. And because the challenge here is the investment. Because a national LEO constellation is not possible. A global NEO constellation is what will work economically. So this is something which you have to understand and how we can create a global constellation meeting the national demand. Right. So one way is to collaborate, another way is to develop independently. Right. So these issues are currently being discussed. But for India, a nation like India, geo-based communication system is still very good, and it is less critical to be compromised if you do it properly. So we can meet most of the requirements through geo, but low latency communication still has a challenge. So there is a possibility that a minimal LEO constellation could be developed to handle such issues.
Yeah. Primarily, the reason why I ask this question is because, take the Navy's GSAT-7 Rukmini satellite or even the one GSAT-7A for the Air Force. These are in GEO, so obviously there's latency, like you pointed out, 0.5 seconds or 1 second delay. Plus, the data speeds are also comparable to what we used to get 10 years ago on our phones. But these days, SpaceX and, Starlink is able to give 150, 250 Mbps. So this changes the nature of war, and we've seen that in Ukraine, Russia. So this is also a threat, right? A commercial actor being able to play geopolitics in different parts of the world.
See, you talked about the low rate of communication. I think many of the conditions of critical communication can be handled with that. See, when you have very high data rate, that only will help you. I think we don't have to have such narratives. What is needed for the purpose, whether it is available? That's a question, which is definitely possible from geo. There is no doubt about it. When you have a high data rate available, of course it is good, but it is not a mandatory requirement to handle critical information. So there are other ways to handling high data volume communication. For example, edge computing in satellites can handle reduce the data communication demand to a lower data, but still provide the necessary intelligence. So there are other ways of handling it.
So, sir, when it comes to constellations, there is also the possibility of using GPS. I mean, on a global scale, an Indian version of GPS. Now we have Navik, Indian subcontinent, and 1500 kilometers away from the Indian subcontinent. Any plans to, make this a larger range? Because our ambitions are growing and our requirements are growing.
What you said is right. So currently the Navik with the 7 satellite constellation provides only that much range, 1500 kilometers beyond the Indian boundary. But for us to operate, especially the strategic assets start to be operated beyond that, need a assured signal of that class, which requires expansion. So there are different ways of expanding it, which is currently under discussion. One of them is a geo ways of expand. Adding more satellites in the geo can expand 1500 to 3000. But that again limits it becomes a regional system. So the question is whether it need to remain regional or whether we need to make it a global. So global is possible provided we make a MEO-LEO constellation coupled with the GEO constellation. Such ideas are being discussed, and we'll have to figure out the merit of both of them and commercial utilization of this, both strategic and commercial, because no such large constellation can survive with one user alone. It has to percolate into various other capabilities, including maritime use, airline use, personal travel use, all those. So, coupled with the strategic and civilian use, an expansion could be taken up because NAVIC has an advantage today because it gives a better accuracy on Indian continent, especially because of stationary satellites, unlike the moving satellites that are there in GPS, which gives us a lower accuracy. So we have to capitalize on that aspect.
So also finally coming to again one aspect of launch vehicles. So for almost a decade and a half or 2 decades, India has been developing the semi-cryogenic engine, kerosene liquid oxygen. So why has this program taken a considerably longer time than other engine developments? Of course, it's complex, the most powerful engine yet. So tell us more, please.
Engine developments are like that. See, if you look at every world over, no engines were developed less than 10 years in the West. And even 10 years was not enough. 10 years it has reached some level of confidence, but it took another 5 years to put it in operation. It is true of most of the engines of the world. So we don't have to blame us because it has taken time, because it is not our own engine. It was an aqua technology. So that it has its own challenges, because aqua technology we don't get everything, which we have to learn ourselves. And another important question is it had so many new materials which we are not having. It was all coming from somewhere else. Everything has to be indigenized and mastered. Of course, it has to test from incrementally to that full level. So it has taken that challenge, and many a times we face failures and problems. So that's why I am taking a conscious view now. We should not. We should develop something which is with a very strong tie-up of knowledge transfer, including knowledge transfer, and including manufacturing knowledge transfer. We took so much of time in the manufacturing knowledge itself. It's not the technology of this engine that we know, how to make it in India. So this is another big issue, because industrial knowledge is very limited in terms of welding, manufacturing, alloying, heat treating, coating, etc. So this is a major challenge for any complex nature of such project. You know about our aircraft engine stories. Even aircraft engines we were not able to build even after so many years. So because of the nature of the technology, the materials that goes in, the alloying which is to go in, the conditions at which work are very strenuous, and life is a major issue for all of them.
But those in the aviation sector say that rocket engine is once you fire it, it is then discarded. But aviation engines have to fly for 10,000 hours together. So they say it's exponentially more complicated.
See, each one can tell about the complexity that they face, but you look at the power of the comparison. One, of course, this is true that aircraft engines requires a higher reliability because human life is connected to it. Rocket also are going to be connected, when the GAGAN is used. Though it is short time, it has to work well. But you also understand rocket engines are much more powerful than the aircraft engines. For example, the typical C25 engine, which develops only 20-ton thrust, its power of the turbine is 30 megawatt. Okay, 3 megawatt. Sorry, I made a mistake. It's a 3 megawatt. The semi-cryogenic engine which you are developing 200-ton thrust, its turbo pump power is 30 megawatt. So, and 30 megawatt power is developed in a very compact mass of 500 kilogram mass of turbo pump, and which rotates at speeds like 40,000 RPM, where the aircraft engines looks at much smaller speeds. So the conditions of operation and temperatures are much higher than what the aircraft engine sees. And the sealing and the fuel that used is liquid hydrogen, not kerosene. Not explosive. You look at temperature is minus 20 Kelvin and 70 Kelvin. So the challenges are different. So each one has its own criticalities. That's why rocket engines are also made only by very few selected people, like the aircraft engines. So let us not leave it that. So, but we were able to master certain amount of capability, which is very good. But of course, it has to be scaled up. Like we'll have to now make a 200-ton class of reusable engines. Similarly, a 100-ton class, again, throttleable engine for the future for us to vertically land. All these are challenges.
So about aircraft engines and aircraft itself, ISRO is not stopping with rockets. You have the space plane RLV, the second autonomous landing conducted now. What's the future of this vehicle? What will it be used for? These are, of course, very strategic. Boeing X-37B, China has this Shenyang type of plane. So very strategic nature, very, closed use. But what does India look at?
We are looking at as a reusable rocket because it brings down the cost of access. The winged craft has not lost its relevance even now, because in a configuration where the rockets are becoming multi-staged, the bringing the first stage back on land has been already proven by SpaceX, but upper stages are still consumed. If the upper stages has to be used, then the only way is to have winged rocket. Otherwise, it has to become like a crew module capsule type. So that's the only two ways to handle re-entry and aerodynamics. So we don't want to leave that winged craft concept, but the payload fraction in such a vehicle is smaller because the vehicle mass itself is higher. So the whole challenge is how to do an optimal configuration of a winged craft with a lightweight and reusability at a lesser cost than compared to space shuttle era. Space shuttle was a very heavy vehicle. So this studies are continuing at various places like what you mentioned. We also want to invest in it to make sure that we create that capability on a long period of time when we have an upper stage reusability is called for.
So now, for at least 3-4 decades now, ISRO has been outsourcing a fair share of routine work to reliable Indian industry partners. At least 90% of a launch vehicle cost goes to industry, right? So now startups are coming up. They're doing their own rockets, own satellites. Can we see a future where routine rockets and satellite missions, the government of India outsources to the private players because they need to sustain?
The question of routine in space is not a very easy thing because it is not like a aircraft taking off and landing like in a typical commercial operations. Rockets are not operating like that unless you have a large constellation to be maintained. For example, SpaceX maintains 5,000 satellites and they want to replenish on a routine basis. We are not doing it like that in our country. Every mission is unique and special. So, but then large amount of this work can still be transferred to industry, and we are looking at it. And we have already started the program of PSLV going to industry in that manner. And we are continuously improving. This element of continuous improvement is very important for this sector to keep the cost as well as the tech innovation to coming in. Unless the industry has an engineering capability to innovate and remove on its own, it will become only a production task of the industry. They will not acquire the knowledge to do it themselves. My challenge today is to make an industry capable of understanding rocket and do it themselves. Both has to happen. It's not enough that they understand how to manufacture and launch, but then go to the inner element of the understanding of why this and then take an action to improve it over a period of time. So we will work on that goal of industries to be reached, but it takes time because it requires a lot of years of knowledge development on multidisciplinary nature, and we are continuously working. One of the example we are trying to do is SSLV. SSLV being a simpler rocket, I believe that this knowledge transfer can actually take place. We are expecting the industry who is going to take up SSLV to work with us for 2 years. And when they work with us, with specific people for 2 years, they will understand why we are doing all of this and what is the nature of those decisions for each of those design choices. And this is very crucial for anybody to understand.
So also about startups, I was also mentioning outsourcing to industry as a question about ISRO outsourcing some tasks to startups, launch activities to startups, Government of India outsourcing to startups. They have their own rockets and satellites. So if you want to offload some sort of satellite building work to them, is that a possibility?
See, I do not know whether it's offloading. Such concepts are coming only if you have a huge number of order existing that you are offloading. We don't have that. See, if you look at it is coming based on user demand, and they are very discrete numbers. So what we can look today is in those discrete number of satellites, how much of private company involvement can be there, because everything is freshly engineered. Its new designs are involved. It's not a production item. So because not being a production item, the full offloading, that concept of offloading does not take place. But in rockets, significantly possible because of the propulsion modules can be at least standardized and produced. But in satellite, this remains as a major challenge because satellites contain two items. One is called bus, which is a standard item, and second item is called the payload, which is it's a varying item. And payloads evolve with the time, and utility of the satellite evolves with the time. Unless you make 10 identical satellites, there is no way to productionize. Yeah.
So finally, sir, there was a launch calendar that the government had released this year. In about 15 months, close to 30 launches is what is being proposed. So of course, a good number of them is by the startups. You can't comment about them. But about the government's launches, ISRO's launches themselves, how do you see things progressing?
No, it's progressing well. I'm very happy about most of the work which is happening. The satellites do take its own due share of complexity, because many a times testing, validation, reaching up to the final goal remains a major issue for satellites. So there could be little bit of delays here and there, but that should not deter us. We are trying to cope up with the missions that are targeted now. Here we have the almost 10 launches remaining to be completed, and we are on it, including GAGAN missions. Yeah.
Also, Sriharikota spaceport being modified for GAGAN.
The modifications are already been done. The modification of the rocket is already over. The launch pad is already nearly completion. The facilities for handling control of the Gaganyaan program is already near in completion. The assembly facilities for the crew module and the service modules are already been used, ready and used for the test vehicle missions. So in a way that we are ready at launch pad for handling the first human space flight.
So not just confident about fulfilling, dozens of launches in a short span of time, but also confident about the way the Gaganyaan mission is progressing, and also confident about executing the NASA ISRO synthetic aperture radar mission, and also the Indian astronauts traveling to the space station this year. That was Dr. S. Somanath giving us a very comprehensive interview on the Indian space program and the way ahead. From Satish Dhawan Space Center, Sriharikota, Siddharth MP, WION World is One.